Hello Math 8 students, this is Utah Middle School Math Project 5.3c, Features of Graphs, or Features of Functions. In our last lesson, we talked about what a function is. I had students in class visit with their groups to summarize what they remember from our last lesson. So I'm looking for volunteers now to share what do you remember about what a function is. I need more hands in this, please. Thank you. Get us started, please, Seth. Okay, a function has an input and an output. There's lots of other relationships that could have an input and an output that are not functions. So although a function has an input and an output, what specifically makes a function versus something that's not a function? Jaden? One-to-one, not ratio, but a one-to-one relationship. Yeah, one-to-one relationship. So for every input, there is one and only one output. So understanding that there is an input and output is helpful, but specifically for every input, there is one and only one output. And that means when we're looking at a graph, that means they should all pass the vertical line test. Today, we're going to be looking at graphs of functions. Every one of these is a function. Some of them are going to look very different than things that you've seen in the past, but it's because we need to understand features of these functions or features of the graphs. So to get started, we have in the packet that I've passed out, you'll see the first page, which is this and this. And then if you flip that on the next page, which looks like this, there are a bunch of different graphs. And those are the same graphs that have already been passed out to you as a card sort. Okay? That's kind of messy. Here it is, very tiny, but none of them are overlapping. What you need to do first is with your groups, sort them in some way, shape, or form. Sort them into some sort of categories, things that some of them have in common. I'll wait. You might have 2 groups, you might have 10 groups. That is up to you and your group, how you decide to sort them. Once you have them sorted into some categories, again, skipping ahead to that third page, you're going to see down here a place where you can write down and categorize or name what you categorize them as. So what is the name of the group, what's happening in that group, and which graphs would be in that group. For example, graph O and graph P might be graphed together or in a group together, and so you'd list them here, O and P. That's all that I'm going to give for directions for right now. Your job is with your group, sort through each one of these, forming at least 3 different categories. I think is sufficient. Any questions? Okay, with your groups, ready, set, go, and we're going to pause recording. Okay, students in class have sorted them into various categories and listed their categories, giving it some sort of defining name like dots or lines or squiggles. Now, instead of taking time to go over that for every group in class, we're going to kind of switch gears a little bit. Lucy was in a group, and Lucy grouped hers like this: ACEKMP. Find ACEKMP, put those in front of you. Make sure that everybody in the group can see them, which means you might need to kind of stand up out of your seat so that you can all see them at the same angle. ACEKMP. And guys, this is in your packet too, so you can look at your own packet as well to follow along. And voice is off. Now that everybody can see ACEKMP, Lucy labeled those increasing on the entire graph. Think about that. What do you think increasing on the entire graph means based on that description? Good, I see a hand. Now find I, because Lucy labeled I as decreasing on the entire graph. Maybe that helps to solidify increasing and decreasing. Turn and talk to your groups. What do you think increasing and decreasing means? ACEKMP, here we have those, ACEKMP. With that in front of us, what do you think it means to increase across the entire graph, or even just to increase in general? Gracie?
It starts near, like, kind of near the bottom left.
Starts near the bottom left and goes up. Okay, and that's the key thing. We've talked about this before. How do we always read graphs? Left to right, exactly. So we talked about this when we were finding slopes of lines, figuring out if it was positive or negative. But if I read this graph from left to right, so that means I'm starting on the left, which direction is this graph going? Okay, you guys, listen. You never answer this question the right way. As we go from left to right, yes, I know I'm going right. That is not what I'm asking. As I go from left to right, which direction is the graph going? Up. And when it is going up, that means it is increasing. Look at this one. Even though it's dots, as I go from left to right, what direction is it going? Up. So it is increasing. Even this one, you will learn a lot about this type of function next year. Even as we go left to right, even here, it doesn't feel like it is. If you zoom in, you will see that it is going up. It is increasing. So this really solidifies this when I can see I, which was labeled as decreasing, because as I read it from left to right, I go to the lefternmost part of the graph, which is all the way over here. And as I go from left to right, which direction is it going? Down. That makes that decreasing. And then we can really solidify that with F. What's happening in F? Yeah, nothing. It's not increasing, it's not decreasing. So what did Lucy call this graph? Not consistent, but constant. It is constantly -1. So this is constant, neither increasing nor decreasing. So with that in mind, what do you think increasing, decreasing, and constant mean? Put them in your own words first. That way you can remember it. What does increasing, decreasing, and constant mean? We're going to pause recording as students take the time to discuss and write. I hope when you did this on your own, you wrote something along the lines of this. As we go left to right, the graph goes up. As we go left to right, the graph goes down. Key thing that we need to remember, and this is important, even if you didn't write it down, you need to remember that we read graphs from left to right. The reason that is important: if I am not reading this graph from left to right, what could I say about this graph the way I'm tracing it? It looks like it's going down the way I'm tracing it, right? So we have to make sure that we're consistently looking from left to right, because if I look left to right, this graph is actually going up. It is increasing. So let's really put this to practice. Will you please draw an example of a graph that is increasing? Draw an example of a graph that is decreasing, and draw an example of a graph that is constant. We'll do number 7 together, but I want you with your groups, put this to practice 4, 5, and 6. Draw a graph that has this specific feature. Pausing the recording again. Something that is increasing. It doesn't matter where I start, but on the left-hand side, as I go from left to right, it should always be going up. It doesn't have to be a straight line. It doesn't have to be linear, but it does always need to be going up. One that is decreasing, doesn't matter where you start, but as you go left to right, it should always be going down, whether that's linear or non-linear. It should always be going down. And one that is constant, it is not increasing or decreasing, so this would be like a y equals, and then just having a y-intercept, y equals 5. That would be constant. So now, what could we draw for an example of a graph that is increasing and then decreasing? What would that look like, Brock? And go up, if you want to go up and do it up on the board, you can, since it's going to be kind of hard to describe. So go draw that. Okay, not too shabby. What is happening right here, though? Is this a function? Is this going to pass the vertical line test the way it's drawn? So that part makes it so that it is not increasing. Even though you drew it up, you didn't go left to right. So let's go and make a change there. I like the second half. You drew the decreasing perfectly, but we need to make a change to the increasing. Let's go with Hayden. Peyton, will you please go up? Yeah, I think that's much better. You went from left to right as you drew up and continued left to right as you drew down. So this, I'll wait. Still waiting. This is the piece where it is increasing, and this is the piece where it is decreasing. Now let's move on to the next person. This person, Ellis, grouped B, E, and O together, so please find B, E, and O. Ellis describes B, E, and O as discrete. And then all the others, A, C, D, F, G, H, I, J, K, L, M, N, P, is continuous. Talk with your groups. What do you think discrete and continuous mean? Here's B, E, and O labeled as discrete. Put it in your own words. What do you think discrete means? Sam? Dots. Yeah, it means dots. There's a little bit more, but dots is a really basic way of understanding what discrete means. With that in mind, I can't even show all of these because they will overlap. There's so many of them, but these are all the remaining ones. What would you describe these ones as? She described these, Ellis described these as continuous. What do you think continuous means? What does continuous mean? Fitz? Okay, the line goes on continuously. Are they all lines though? No, they're not lines. Okay, things that go on continuously. Who has a different way of describing it? Danielle.
I would say they're all kind of like solid. They're not as solid as the other ones. There's not like solid, like they don't have any gaps.
No gaps. Okay, so solid, no gaps. Because they're not all lines, right? Last one. Okay. Do you think that this pattern could continue off of this grid though? Yeah, it probably does. What about this pattern? Do you think it continues off the grid? Like if I expanded this grid a little bit more, could we still put more dots? Yeah. So that's the one thing that I want to make clear. And even this, yes, it only started here, but if I expanded it, do you think it would continue on? So I want us to make sure that we understand continuous appropriately. Continuous does not refer to how it continues on or how it started, right? That is not what continuous means. If we define discrete as these dots, continuous is, again, it's not necessarily about what happens on the ends. Continuous is about what's happening where we can see it. Here's the way I like to talk about them. Discrete is like a dot to dot. Continuous is like a dot to dot that's already been completed. It's been done. So what I mean by that is, and you will graph these eventually, when we were graphing lines like this, we would say, oh, here's a point, and here's a point, and here's a point. And then what did we do? We grabbed our ruler and we connected them all. So it's like a dot to dot that has been connected. And it would be the same thing as you're learning how to graph all of these other different functions. You would start with just a dot, and then another dot, and then another dot, and eventually you'll just connect those, and that will make that continuous. And so, if discrete is like a dot to dot that has been left incomplete, continuous is like a dot to dot that's been done. I believe somebody described it as no gaps. Was that Danielle who described it as no gaps? Another way to think about it is When it's discrete, I have to pick up my pen every time I want to plot a new point. Pick up the pen, put it down again, pick up the pen, put it down again, pick up the pen, and put it down again. For continuous, I can trace the entire thing without ever lifting my pen. Okay, that's what continuous means. So maybe we can add something like that as well. Can trace without ever lifting pen. One thing to understand, again, continuous does not mean that it continues infinitely on. We're talking about the behavior that we can see. There's no gaps. All of the dots that existed have been connected. So draw an example, put this to practice, draw an example of a graph that is discrete, draw an example of a graph that is continuous. Notice it doesn't say anything about increasing or decreasing, right? So draw one that's discrete, draw one that's continuous, and I'll ask for volunteers to come and put them up on the board. We're going to pause the recording as students work on this on their own. Okay, I'm going to send 2 students up to the board to go and graph discrete and continuous. They're going to show examples, so go ahead, go up there. There's 2 pens, you guys can both go up there at the same time. Great. Gracie drew that without ever lifting her pen. And Sam has to continue picking up the pen and putting it down in order to draw this next one. Notice what Sam is doing. Sam is still making sure that it passes the vertical line test. This is still a function, right? Because how many points is it going through? 1. Ooh. Ooh. Let me move just, nope. Let's erase this one. All right, there we go. Now it passes the vertical line test. No 2 points stacked on top of each other. That still passes that vertical line test. Okay, great job. And now put them back in order A through P so that we can have our final discussion. A through P so we can sort them easily. Grace grouped hers A, E, F. So once they're in order and you can easily find A, E, and F, pull those out. This was a grouping that I saw a lot. Not quite as many people in their groups put them in 3 categories here, but linear A, E, F. So here's A, E, F described as linear. And then the next one, all of these ones were described as nonlinear. And these ones here were described as, I can't remember, what were the words? Made up of pieces of lines or something like that. What was it called? Made up of pieces of linear functions. Okay. So based on that, what does linear and nonlinear mean? And why are these not considered linear? Talk with your groups. Talk with your groups. Pausing the recording. These ones are called linear. What do you think linear means? This isn't really a new word, is it? What does linear mean, Cade and S? Yeah, linear doesn't necessarily mean has slope, right? But what does linear mean? There's another way we could describe it. Seth? Yeah, it's just a straight line. Just a straight line. Yeah. Okay, what does, these ones were all categorized as non-linear. So if linear is a straight line, it makes sense that these would be non-linear, because are any of these straight lines? No. But these all have some straight pieces in them, right? So why are these not classified as linear? Why are these not classified as linear, Gabe? Yeah, it's not one straight line. It's a piece of a straight line and another piece of a straight line. Eventually, you will learn more about these. Some of these functions have names like O and D are absolute value. But all of them can also be written as piecewise functions, which you will get to in 10th grade. These are piecewise. But key thing is, even though they have linear parts, they are not technically linear. And so let's put those in our own words, coming all the way back. What does linear mean in your own words? I think it's safe to say that linear means a straight line, a line. Fun fact, if it's a linear or a straight line, it has a constant rate of change. So there was some hint about slope saying, well, this one doesn't have slope. It does. The slope is 0, which means it's constantly going up 0 every time it goes over 1. So it still has a constant slope or a constant rate of change. Nonlinear would be not straight lines. Which also means down the road, and you will learn about this quite a bit more in future years, there is not a constant rate of change. These are the features of functions that you need to know. And let me skip all the way ahead to, have I made it to the homework section already? Okay, so for homework, you get to put this all to practice. Let's use this time to work on some homework since we've got 7 minutes of class left. It says to draw a graph with the following features. So it needs to be increasing, it needs to be linear, and it needs to be continuous. So what is that going to look like if it's increasing, linear, and continuous? Try it on your own paper first, and we'll have someone go up to the board to give it a try up there. Increasing, linear, and continuous. Do I have a volunteer who is brave enough to try it up on the board? Okay, let's go Daxton, give it a try. Increasing, linear, and continuous. That's perfect. It's a straight line. It is going up as we go from left to right, and he traced the whole thing without picking up his pen once, so it fits all of those. Increasing, linear, continuous. Let's try something else that's more challenging. Please go to number 4, constant and discrete. Constant and discrete. Try number 4 on your own paper first. What does constant mean? Make sure it's discrete. Volunteers? Tage? That's why I called your name. Okay, great. Constant because it is not increasing or decreasing. It is discrete. It is just a collection of dots. Multiple times he had to pick up his pen and put it back down in order to do that. Let's save the rest of them for homework. Let's move over to the next section, which is also homework. For these ones, you need to describe the features. So, increasing, decreasing, constant, discrete, continuous, linear, nonlinear. Let's jump to 9. What are some words that I could use to describe what we see is happening in number 9? Caden. It is decreasing as I go left to right. It is going down, so this is decreasing. What else could I use to describe this, Seth? Nonlinear. It is not a straight line, so this is nonlinear. And what else would I use to describe this? There's one more word, Gracie. Continuous. That is it for today's lesson. Anything not finished in class on this homework section is going to be homework, so not too many problems. A total of 12, some of them we've already done in class. Thanks for watching. We'll see you next time.